Good day, we are.
Group 1.
I'm Marlon Antonio.
I'm Carl Gerard Biclat.
And I'm Nicole Kim Vitug.
We are representing our project, which is Bounce and Collect.
Bounce and Collect is a game created using assembly language. It is simply played by moving the ball that will collect all the coins and place in the map and must avoid the spike or trap in order to finish the game. Once the spike or trap is hit by the ball, the game is over.
Continue watching for more details, and if you have questions, just comment down below. I will be explaining to you now in full details what our project is all about. Bounce and Collect is a game created by using assembly language. It is simply played by moving the ball that will collect all the coins placed in the map and must avoid the spike or trap in order to finish the game. Once the spike or trap is hit by the ball, the game is over. For our problem statement, our group wants to create a game that is simple and easy to use, where all the people can play without the need of having a gaming console or doesn't need to have a good graphics that most computers or laptops has in order to enjoy the game. We want to create a game that is cost-free yet challenging to play. The main goal of our program Bounce and Collect is to be able to collect all the coins placed in the map without hitting the trap or spike, or else the game is over. The user can move the ball using the arrow keys in the keyboard. The left click of the mouse is used for tackling the spike or trap in order for the ball to avoid it. The right click of the mouse is for resetting the level. Keys 1, 2, 3, 4, and 5 is used to navigate levels. Escape key is used to exit the game. For the objectives, the first one is to apply the lessons discussed in the Assembly Language Programming Laboratory class. And the second one is to create a game that is integrated by the following interrupts. Interrupt 10H for video setting, interrupt 16H for keyboard inputs, and interrupt 33H for the mouse. For our scope and the limitations, Bounce and Collect has a limit of 5 levels only, and the common interrupts used are int21H, int10H, int16H, and int33H. Bounce and Collect is kind of similar to the mobile game series Bounce that was published by Nokia. In Bounce, the player controls a red ball with the requirements to go through all hoops. The ball can also become big, allowing it to float in water areas. The enemies come in the form of static obstacles as well as moving blue, spiky objects, and firm yellow candle objects. The differences between Bounce and Collect and Bounce are: first, Bounce is a mobile game, while the Bounce and Collect is a game that runs only in the DOS box using computer or laptop that has MS-DOS box. When it comes to obstacles, Bounce has a lot like the moving spiky objects, firm yellow candle objects, while the Bounce and Collect only have one obstacle, the spike or the trap. Hitting that ends the game. And lastly, Bounce has many levels that if you win the level 1, you will be prompted to level 2. Unlike the Bounce and Collect, the levels are limit up to 5 only, and the user can choose freely which level they want to play. For the methodology, the first part of it is about flowchart, and I'm going to show you first the flowchart of the main menu. As you can see on the screen, the top of it is the menu. Next is the load menu graphics, then initialize keyboard and mouse buffer, and you will encounter a decision block asking is there a key press. If yes, another decision block asking is it for escape. If yes, you will be prompted to the exit menu. If no, another decision block asking, is it in the range 1, 2, 3, 4, or 5? If yes, you will be prompted to the play menu. If no, you will go back to the initialized keyboard and mouse buffer and encounter again the first decision block asking, is there a key press? And this time, if you answer no, you will be asked another decision block that asks, is there a mouse click? If no, you will be prompted to go back to the initialized keyboard and mouse buffer, and again a decision block asking, is there a key press? And if you answered no, same question, you will be prompted to another decision block asking, is there a mouse click? And when you answered yes, is it for play? If yes, you will be prompted to the play menu or the play interface. And if you answered no, another decision block asking, is it for clear stat? If yes, you will be prompted to the clear stats menu. If no, another question, another decision block asking, is it for help? If yes, you will be prompted to the help menu. If no, another decision block asking, is it for exit? If yes, you will be prompted to the exit menu. If no, you will go back to the initialized keyboard and the mouse buffer. And I hope you understand that. Okay, the next one. The play flow chart from the top, the play. Next is the game variables, then loads the platform and ball. Next is to initialize the keyboard and mouse buffer, and the decision block asking, is there a key press? If yes, is it escape? If yes, you will be prompted to the menu. If no, is it the arrow keys? If no, you will be prompted to initialize keyboard and mouse buffer again. Then, another same question, is there a key press? If yes, is it escape? If no, is it the arrow keys? If yes, the ball move. Then another decision block asking, did the ball touch the spike? If yes, you lose. If no, did the player satisfy the game condition? If yes, you win. If no, you will be go back again to the initialized keyboard and mouse buffer and asking the same question, is there a key press? Then this time, if your answer is no, another decision block asking, is there a mouse click? If no, you will be going back again to the initialized keyboard and mouse buffer. Then ask the same question again, is there a key press? If you answer no, is there a mouse click? If yes, is it the left click? If yes, this is where the spike toggles. If you answered no, is it the right click? If yes, the game will reset. If no, you will be going back again to the initialized keyboard and mouse buffer. I'm going to show you now the user interface of our program and later on its demo version. The first one is the main menu where you could see the play, clear stat, help, and exit. Next is play. Next is the game over display. And last is the help menu where you could see the instructions and the controls. Next up is the demo version. For the demo of our program, let me start first from showing you the play menu, the use of arrow keys, and the use of left and right click of the mouse. When you click the play menu, you will be prompted to the playing interface where you could play the game. You can see that from using the arrow keys, you can move the ball upward, downward, and sideward to collect the coins in the map. And the spike, the light green square one that has a red dot inside of it, the one that toggles faster from its original position to the other side. The left click of the mouse was used to toggle that spike. The right click of the mouse is responsible on resetting the game, which you can see now in your screen. And on the upper right corner, you could see the coins counter, moves counter, and the previous best display. Next one, I'm gonna show you the game over display. Remember, hitting the spike will lose you the game. You can go back to the main menu by pressing the escape key. Now, I'm gonna show you how to navigate levels using keys 1, 2, 3, 4, and 5, the inside of help menu and exit menu. Clicking keys 1, 2, 3, 4, and 5 will lead you to different levels. In our program, you can choose freely which level of the game you want to play. Just click the keys from 1 to 5. For the help menu, you could see there the instructions and controls. While for the exit menu, clicking it will exit you from the main menu interface. Like what I said earlier, you can also exit by pressing the escape key.
Hello guys, I'm Marlon Antonia and here to discuss the first part of our project, which will be the variables and the main menu. So as you can see, here are all the declarations of the variables. So, especially this ref x and ref y will be used later on to draw the block, ball, spike, and the coin. So this will be much used later on. So here are the string coordinate of the coin, moves, previous moves, level, and so on. So here in the mouse information, as you can see, this click status will be used later on. So if it will be compared if either it's 1 or 2. So 1 will indicate left click, or 2 will indicate as right click. Since left click will transfer the clickable spike to another coordinate, and the right click will restart that level. So here is the key press that has been set, the escape key up, down, right, and left. So here in this ball status, you will see later on that there will be a BT ball status. It's either 0 or up to 3. So means 0 means that it stopped or moving. 1, it collide with a spike. 2, it collide with a coin. And 3, it passed through a switch block, which will be in state level 4 and level 5. So this bit will be transferred to the carrier flag of the ball status. So here the video page, video mode, just to set the video mode, or select a video page since we will be transferring from one page to another. Here the game stats, just the declaration for it, the messages, it's either game over, level complete, so the coins, how many coins has been collected, how many moves that has been made, the previous best, the perfect means that you collect all, and you set the minimum, and this level we just showed what currently level are you in. So here are the button, the play, the help, the clear stat, the exit. So this is the title, our project, bounce and collect the menu, and this the strings of group 1, and here is the content of the help when has been pressed. So here is the file data. The game will automatically save when you made the minimum move on that level, or rather in that level. So now let's start with the code. So first, of course, initialization, then setting it to the video mode, then load progress if there's any. This will be discussed later on by my other group mate. So, of course, clear the stats, everything to to the initial settings. Then we call the main menu, or then if it's in main menu, then the mouse pointer should be showed up. So here in the wait queue, we're going to get the status of the keyboard buffer. So if it's not zero, it's a zero flag, then it will jump here, the key press, for waiting to a key to be pressed. Then we'll compare it either to 1, 2, 3, 4, 5, or the escape key. So to jump mazes, it can be made just pressing the what. If you want to go to the maze 5 immediately, then just click 5. So this is the escape just to quit. Then if not, then there's nothing, there's no click, then it will just wait until there's one. But if there's no key, just call the main menu again, then jump to the wait key. So here is the level to call the level 1 maze. So it first hide the mouse pointer, since we won't be needing the mouse pointer in the game. So calling the maze 1. So in the maze 1, if the ball collide with a spike, so the ball status, the clear flag of the ball status should be 1 to indicate that it break. Then if that condition has been made, the show game over will be called, or rather this will jump to game over to show that the game is all over. But if not, we'll just be waiting for any key to press. If the game is accomplished, just press any key to be able to move to the next maze. So the level maze 1 is just the same for the rest, so I'll be skipping this part. So here this shows that the clear stats, just clearing the progress and still hiding the mouse pointer. Then back to the menu again. Here this shows the game over. Just to display game over, then press any key, then you will be able to go back to the main menu. This just show the content of the help. So it will clear the screen, display the content of the help, then press any key to go back to the main menu. So here is the quit. This is the save progress and exit. So in this one, this just shows the coordinates to the block in the main menu, which will be this all. So all in the side. So here will this code or this part will just display the group name, here the menu title, and here the play button, here the clear stats, this for the display for the help as according to the comment, and here is the exit. So that's mostly all for the main menu and the variables. So later on, I'll be discussing the mazes and other functions as well. This part is all about mazes. I'll be starting with maze 1. In maze 1, it will first call the clear screen, which will clear everything in the main menu to be able to output what will be in the maze 1. That will be the move counter, point counter, level, previous best moves, maze border. And first, we will first position the maze 1 in the 8080 XY coordinate. So to be able to do the maze, we'll first transfer the initial position of the maze into a reference X and reference Y. So after that, we will add some values to the reference X to be able to add a block or to do a block into the maze 1. So here we will set our counter into 3. So which means this will loop 3 times. So there will be expected 3 outputs of blocks, which will be these 3. So after the loop, so the ending reference points will be in this point, which will be the 12080. After that, there will be an add in the reference Y. So it will go down, which will be in this reference point will be 12090. So initializing again the counter into 2. So there will be another 2 blocks, which will be these 2. Then initializing again the counter by 5, which will be these 5. So everything in this code is all about outputting or doing a block into the maze. So it will all be the same. So I'll be moving on to the next part. So here in the ball, we need the constant initial value of the coordinate of the maze, which will be 80, transfer again to reference x and y, adding it. So the reference point here now will be 100, 100. So that 100, 100 will be in this part. So this is the initial position of the ball. So same goes with the coins. We're going to initialize again the initial value or initial coordinate of the maze. Then adding some values to it, which will be 50 and 40 and will be in your reference point. Adding some 10 in the reference x. So there will be 3 coins output since we initialize the counter into 3. So there is another coin in here, so that will be for this part. So now for the spike, this is a clickable spike which has a turn on and turn off. So this is the turn off state of the clickable spike and this is the turn on state of the clickable spike. So this is just more positioning, and this function clickable spike will be later on discussed by my other group mates. And the same goes with the other 5 functions that I've said before in the starting. So now here is the maze 1 animation. So in here, the minimum moves has been set. So these minimum moves will be compared to the moves that has been made by the user. So that it should be compared whether it will be the minimum move that can be made on that level. So here the BTR. So this 0 will be transferred to the carry flag of the ball status. So to know either it is stop or moving or collide with a spike or coin, or later on there will be a switch block. So here we set the max coin for this level, transferring that max coin into the AL and comparing that coin, which is this coin is the number of coins that has been obtained in the map. So when this coin is equals to the max coin, it will be saved and the level is done and can move to the next level. So this part is waiting for getting the value of the keyboard buffer. So if not 0, then it will go here. So waiting for a key press. So that key press will be transferred in here. So might be but it can directly be compared to escape key. If escape key, it will jump to the escape function and go to the main menu. Or rather, it can be a right click to restart the game. So this up, down, left, right, it will jump here so that the moves can be counted, and still the ball status is 0 since there's no collision happening yet. Then it will jump here again in the wait key until all the coins has been collected. So this is still the same, the escape key, but here is the restart. So it will clear the current stats that has been made by the user on that level and will clear the screen again, display the counter, the moves, then back to the start. So in this no key M1 function is only used by said in the comment just to prevent the clickable spike from clearing when the ball passed through it. So just to prevent it, since it's in off state, the ball can pass it, so just preventing it to be gone from that coordinate. So here for this part, we just check the mouse click. Is it either the left or the right click? If the left click, then later on we'll be discussing this whole click. It will just transfer, mostly the whole click will just do is to transfer the clickable spike from another coordinate. Then the release to put it back again to the original. Then the right is just to restart the game. So next will be here. So you'll see there's a check collision. This check collision purpose is to check whether the ball collide with a coin or with a spike while moving. So that is the overall function of the check collision. Now the bit test, which will be the zero, will be transferred to the carry flag of the ball status. So if the condition is met, it will jump off here. The graphic move, compare the key that has been pressed. Then it will reduce since the ball will move, and the same time the coordinates might increase or decrease depends on the axis that it moves. So here it will of course it will draw pixel by pixel with a delay. So here's the escape key press that will clear the stats, and it will show the mouse pointer since it will be going back to the main menu. So here the save maze, when the maze 1 is complete, it will save, then detect whether or not the moves that has been made by the user is minimum. It will compare to the minimum moves that we have set before. Then it will display the level complete at the bottom. So this is the return maze. This will keep the stats like the restart. So here the maze 2. In maze 2 to 5 is almost the same as maze 1, except that maze 2, maze 4, and maze 5 has portal, and maze 4 and maze 5 has a switch block that can be toggled by the ball when it passes through it. So the portal for the maze 2 is in this way. This is the coordinate of the portals. So which will be, this is the portals when the ball moves here. So everything else is the same with maze 1 except that maze 2 has a portal. Maze 3 is the same too. With maze 1, there's no portal in maze 3, while maze 4 has a portal. At the same time, it has a switch block like maze 5. So I'll be skipping this maze 3 and we'll go to the maze 4 to see the switch block and the portal coordinates of it. So here we are in maze 4. So in maze 4, there's no switch or clickable spike, but rather it has a fixed spike that is in the maze. So this is also the dual switch blocker. When the ball passes it, it will become a block. First, of course, it's only in the dot and pass. When the ball passes to it, it will become a block. So here are the coordinates in the portal of the maze 4. So this is almost the same with maze 5, which has a portal and a switch block. So in the maze 5, the switch block is like this. So this color green here is the switch block. When the ball passes through it, it will become a block. So I'll be skipping the rest of the maze 5 since almost the declaration is almost the same as maze 1, just different in coordinates. For the next part, so you can see this is the function, the right click. So in this 33H, the move AX5 means that we will get the information when it is pressed. So that means if 1 is transferred to BX, that means it is a right click. Or if 0, it is a left click. So the BL will be compared to do 1. If it equals, then right click, then there will be a restart of the game. So here the maze 1 mouse click. So in this maze 1, just the whole click of the left click. So again, AX5, press information of the mouse. So since it's 0, it's left click. So this is for the left click. So just the very purpose, just to transfer the clickable spike when of the on to off, FD off to on, just transferring the clickable spike to another coordinate. So here they hold the release click. So this is the vice versa of the hold click. By returning that clickable spike to the original coordinate. So the same with the maze 2, maze 3, and maze 5. Maze 4 don't have any clickable spike in the maze 1. So I'll be skipping at those mouse clicks. So here in the main menu, so press for the press button, press button of the mouse or mouse information of the press button. So this is just for the exit or the play, the help. So the exit, of course, it will be quick, and if the play, it will start to maze 1. Then there's a clear stat. It will clear it will clear all the stats in all the mazes. And this is the help button to display the help or the instruction for the game, which button can be used and which can be clicked. So here the show mouse pointer. When every game go back to the every maze that go back to the main menu, it will show the mouse pointer. So when from the main menu to a level, maze level, anything, so the mouse pointer should be hide. And here this the check collision, which I said that it only check whether it collide with a spike or a coin to know the ball status. Since it is 0, it is either 0, 1, or 2. Since 2 for the coin collision to the coin, and 1 to the spike, and 0 it is state that it's either stop or moving. So here go to XY, just to go to the certain coordinate, and here there is the clear screen, just clearing the screen of the game. So here this BG color is black, so replacing everything by black and setting the cursor position to the initial, which is 0, 0 in the upper left corner. So here it set the video mode. So that's everything for forward. I got it here.
Hi, I'm Carl Gerard Miklat. I will be presenting most of the functions used in this program. First, from line 224 up to 3237, which is the display game function. This displays the game over string, then reset the video page from the start. Next is the display level complete function. This displays the level complete strings, then reset the video page from the start. So the next one is the display coin counter function. This displays the coin strings, then displays the total number of coins collected. Next one is display moves counter. On the first part, this displays the string move. Then it displays the number of moves created. Next is the display perfect function. This simply displays the string of perfect. Then the display help function, which displays the strings that contains the instruction. The following are the previous best moves. On maze 1, you can see the display prev best M1 function displays the strings previous moves for maze 1, then displays the number of previous moves for maze 1. Then followed by the display best M2, which is the same as the M1 but for maze 2. And also for maze 3, for maze 4, it's also the same up to maze 5. It just varies with the variable moves M5 from M5 up to M1. Then next is the label for levels. Display level 1 function displays the string level 1. Then so and so forth up to level 5. Its main function is to display the type of level in the game. Then another game functions are the count coin procedure. So count coin function, first it checks for carry flag from ball status. If no change in the CF, it will return. And then if not, it will go to the add coin loop for counting coins. Then the bottom part displays the string coins, then the display of the number of coins. Next is the count move procedures. Count moves function, first it resets the values of moves. It resets to 0. Then the loop start count moves. You can see the ink tens. This is the ink tens is for the increment for tens place, and if more than 10, if more than 99, it moves to hundreds place. Then it displays the number of moves and the string move. Next is the activate blocker. Basically, activate blocker is the wall of the maze. So from start, it checks for the CF for ball status, and then if no change, then it will return. Push the then the loop starts by pushing the coordinates x and y from ref x and ref y. Then check for ends of maze here in this part. Then it will call the function draws SW blocker on, and finally it pop the coordinates of x and y. So next is clear stats. Basically, clear stats just resets the numbers, reset the number of coins, and reset the number of moves, but it doesn't reset the high score. So it's just for the coins and the moves. So the next is detect min moves, which declares the number of minimum moves you can make in a maze. Then it compares the minimum moves and the actual moves, which if you meet the minimum moves for with the actual move, then you'll get a perfect, and it will call the display perfect function. Then for save moves, basically it updates or save record the number of moves made by the player in maze 1. So save moves M1 is for the maze 1. Then there is for maze 2, which save moves M2 up to maze 5. Then we go for the drawing procedures. So the get pixel color, this function sets the color for a single pixel. So we can do this by using interrupt 10h. Then the draw BG function. This sets the background color. So first it sets the y coordinates to fill color, then the x coordinate, and loop for filling the lines of the x coordinate, and y, also y. Then for the draw pixel. So draw pixel function is for changing the color of the pixel. We're also using the interrupt 10h. Then for the maze 1 border function, this sets the coordinates of x and y axis. Then this This sets for the offset of the border. Then we call for the draw border function. So the following instructions, this makes the unique border for the maze 1 and also for the x-axis and the y-axis. So the maze 2 border is also the same with the maze 1 border, but it has a different border size. You can tell by the numbers here and also for here. This is for the border x-axis and this is for the y-axis. It's also similar to the maze 3 but with the different borders for the x and y-axis up to maze 5. So next is the draw block. The draw block function first gets the xy coordinates and then it sets the pixel color. This loop function is for the x-axis for drawing the red bricks, and this loop is for drawing for the y-axis. While calling draw pixel, you can draw the basically the lines for the shape of the block. Then after that, you need to fill the shape with this by filling the y and the x-axis. So for the draw border function, first, like the draw block function, it gets the y and x coordinates. This function is to draw a border at the extremities of the maze. So then for the draw ball, it's a function similar to the draw block, which gets the x and y coordinates, then sets the color of the pixel, and also draw the line for the x and y axis. Then it fills it with colors. Also for the x and y axis. Then for the draw coin function, similarly to the draw ball function, it gets the x and y coordinates, then create the x and y circle shape, and then fill it with pixel fill colors. This is for the clickable single spikes with the in the right side. So first it sets the x and y coordinates, then sets the color for the spike, then draw the shape, and for the spikes, so similarly, it's draw click spike L. It's the clickable single spike to the left. Draw fix 1D spike is a non-clickable spike. It's a fixed one, similar to the clickable single spike, but it's a fixed one. It cannot be moved. Also, if there's a right, there's also a fixed one direction on the left. So it's really similar to the clickable spike, but this one is fixed. So another one is the draw fix multi-direction spike. So this one is has spikes from both sides. So for this this is the clear graphic element. So the CLR graphic function, basically this functions as a clear skin function. So it first get the x and y coordinates, then gets the background color or the pixel color for background, then prints all the pixel or all the background for the screen. So next, for the file streaming, it closes the file. So the load progress function first open a file using interrupt 21H, the 3DH. Then we read the file using the 3FH of interrupt21. So if there's no file, it will jump to create file function. Then if it sees the file, then it will return the load progress function. Then it will close the file. Then for error opening, basically this will create a file. If there's no file, it will create a file. Then if there's a file, it will open the file. But if the file cannot open, then it will load error message. So for the save progress function, first it will create a file using 3ch in the interrupt 21h. Then it will open a file using 3dh in the interrupt 21h. If the file exists, then it will write using the 40h of the interrupt 21h. Then close the file using 3eh of interrupt 21. Then for the clear progress, this function clears all the moves of the save files. So then the delay, sometimes we use delay using loop function. Then the final function is the exit. So we call the hide mouse pointer and the clear screen function. So that's it. That's all. So thank you for watching. If you have comments or questions, just please write the comments section and we'll try to answer it back. So thank you.